Hello everyone. So I think that we have a break after the engineering expo that we didn't have a class. So today let's continue what we have learned about the dimensional analysis. Okay, let's recall the Buckingham Pi method procedures. If you remember that, we first need to determine the k relative variables, physical variable related to the problem statements. Second, we will express each variable in terms of basic dimensions, r, either based upon the force, length, and time system, or based upon the mass, length, time system. The next step, we will be able to determine the pi terms. That, for example, you have 6 permanent variables. Now, when you express that 6 permanent variable with a basic dimension of r, which is 3 in this example, then you will end up with 6 subtract 3, will equal to 3. Now, then we choose r over k variables as repeatable variables. Then we perform the pi terms by simply using the non-repeatable one, then with a repeatable one. Then come up with unknown powers. And finally, we solve for all of unknown powers. And then keep performing the same procedure on 5 and 6, and eventually get all of the pi terms. Now express the pi terms as pi 1 equal to function of pi 2, pi 3, and so on. So let's look at one example here. Now this example is to determine the drag force of the car. Now we need to find the physical variable related to this problem. So in other words, the drag force can be related to the length of the car, L, velocity of the car, V, the density of the L, and the viscosity of the L. So we counted, how many k turns do you have? 1, 2, 3, 4, 5. For in this example, k is equal to 5. Then we will choose the FLT system, and we found that indeed there are 3 basic of variable FLT. They all exist in these variables. So r in this example is equal to 3. So we will have 5 subtract 3 equal to 2 pi terms. Now we will choose the repeatable variable r. In this example here, we choose the length, velocity, and the density of the air. Now let's perform the pi terms. That choose a non-repeatable one with a repeatable one, which are L of the power A, velocity of power V, density of power C. So, and here L we express by the LTF system. So the final step will be solving all the index. For this example here, F is 1, F here is C equal to 0, which is dimensionless pi 1 term. Similarly, you can perform the L and T and eventually solve for all of the unknown powers A, B, C. End up with minus 2, minus 2, minus 1. So now you can plug into this ABC you just solved a second ago and come up with FD, L minus 2, V minus 2, C minus 1, and end up with this one. So this one will be the pi dimensionless term. Now if you look at that, FD and L square end up with the same dimensionalized pressure. Rho V square is another dynamic pressure. Oh, these two actually end up with what? Divided by each other, end up with dimensionless term. So we will repeat the same procedure to solve another pi2 because we have two pi terms. So now this time we will use another non-repeatable one. Here is mu. Then you express the same thing and come up with 1 plus c equal to 0, which is force. Length is minus 2 a over power v over power minus c 4c equal to 0. Of course, you can solve this one and end up with minus 1 minus 1 minus 1. So you end up with the dimensionless term mu divided by rho VL. So in other words, we can express a pi1 equal to function of pi2, 3, 4, 5. In this example, we only have two dimensionless pi terms. So we can simply get this relationship, exciting relationship of FD of a drag coefficients, dimensionless drag coefficients, is a function of some parameters, which we will discuss later today. So they give some comments for the DA. Now, if we recall that we will have a physical problem has k variable. In the previous example is 5. Now 3 is a basic dimensions variable. So then we have 5 subtract 3 equal to what? 2 dimensionless variables. So we can express this kind of dimensionless variable by pi1 equal to function pi2, 3, and so on. Now most of the time that we usually will be asked or will be puzzled is that what kind of the dimension, the repeatable variable will you choose? We will usually use a geometry, material properties, or eventually we use external force. But this kind of the repeatable variable will be given to you for your homework or in an exam. If it's not, everyone can choose a different repeatable variable, might be ended up with non-unique patterns. Okay, so this is the one repeatable. We repeat another example we learned about Buckingham Pi method.